So our next section is 3.5. This section is going to talk about solving systems of equations, and in particular it's going to talk about solving systems of 3 equations and 3 unknowns or variables. So if you think back to Alg 1, you would have solved systems of equations where you had 2 equations and 2 unknowns, and there were 3 methods primarily, or that you would have been taught for how you can solve those systems. The first would have been by graphing them and finding the point of intersection. It was probably your least reliable, and you most likely had a teacher tell you that it's not one you can depend upon because it's not precise. Okay, gives you a good visual, but it's not reliable, especially when we get to 3 variables and so on and so forth. The second was probably substitution. Okay, where you solved one of your equations for a variable and you substituted it into the other equation, and when you did that, you ended up with an equation that no longer had 2 variables. Now it only had 1 because you replaced one of them with an expression that contained the other variable. The third method would have been elimination, where you added or subtracted multiples of your equations together so that you eliminated or canceled out one of the variables, leaving you just one that you were then able to solve. All right? So we're going to have the same 2 methods. We're going to have a substitution method, and we're also going to talk about an elimination method here in a couple of minutes. So for our substitution method, we're going to take our equations. I'm going to pick one of the 3 equations, and I'm going to isolate one variable in that equation. So maybe I choose to solve for x or y, or maybe z, but I'm going to do that one time in one equation. I want to do so in a way where I do not introduce fractions if at all possible. Okay, I don't want to deal with fractions with this method. I'm going to then take that expression. So let's, for example purpose, let's say I solved for x in the first equation. I'm then going to substitute that equation into equations number 2 and then also into number 3, both times replacing the x variable. And what I will end up with is I'm replacing the x variable with an expression that now only contains y's and z's. Okay, so I've gotten rid of one of those variables. All right, what you're going to be left with are 2 equations that now only have 2 variables. You're going to set those two equations into a system together, and you're going to solve that system of 2 equations and 2 unknowns using methods that you would have been taught in Alg 1. You're going to continue with either elimination or substitution. Once you've found, in this case, y and z, which would have been those 2 variables left over, then you would plug back into any of your 3 original equations with the values for y and z, and you're going to solve to find a value for x. So let's take a look and see what that is going to look like. So here I've got an equation. I have 2x minus y plus z equals 4. I have x plus 3y minus z equals 11. And I have 4x plus y minus z equals 14. So let me go ahead and get myself just a little bit of room here. All right, so I want to take a look at this and ask myself, what's one variable that I can easily solve for that's not going to give me fractions? So I've got a couple of options here. The first equation I could solve for y or z. Second equation I could solve for x or z. Third equation I could solve for y or z. Also, at least in the back of my mind, once you do a few of these, you might look at some things and realize one way might have more work associated with it than another. But really, any of these methods or any of these variables that I mentioned are going to work out just fine. So for this particular problem, let's go ahead and let's solve our first equation for z. So if I solve my first equation for z, what I'm going to do, I'm going to subtract 2x on both sides, and I'm going to add y to both sides. And what I'm going to be left with is z equals negative 2x plus y plus 4. Okay, what I'm now going to do, I'm going to take that expression and I'm going to substitute it in to equation 2, replacing the z, and then equation 3, replacing the z. Okay, when I do that, so let's do equation 1 into equation 2 for my substitution. So everything of equation 2 is going to stay the same, except I'm going to replace this z variable. So I'm going to have x plus 3y minus the entire expression replacing z. Okay, I'm subtracting the entire z variables, therefore I have to subtract the entire expression here. So minus negative 2x plus y plus 4 equals 11. So what I want to do, I want to distribute this negative into my set of parentheses, and then I'm going to combine like terms. So I'm going to have x plus 3y plus 2x minus y minus 4 equals 11. So I want to combine like terms on the left, and I want to move that constant over to the right. So when I combine like terms, I'm going to have x plus 2x, or 3x. I'm going to have 3y minus y, or 2y. And when I add 4 to both sides, I get equals 15. I've now simplified this substitution into a system of, or an equation with 2 variables. Now I'm going to do the same thing. I'm going to substitute that solved expression for z equals negative 2x plus y plus 4 that I did at the very beginning into equation 3. So I'm going to do equation 1 into equation 3. So when I do that, I'm going to have 4x plus y minus the entire expression again in parentheses. So 2x plus y plus 4 equals 14. Again, I need to distribute this negative into this set of parentheses. So we're going to end up with 4x plus y plus 2x minus y and minus 4 equal to 14. So again, now I'm going to combine like terms. 4x plus 2x is 6x. Y minus y simply goes away. And when I add 4 to both sides, I get equals 18. Okay. This happened to work out really, really nicely for us. And in fact, I didn't try it, and I didn't know it was going to happen that way. At this point, I could go through this equation that I just got here because I eliminated by chance 2 variables at once, and I could solve it simply for that variable x. But let me show you, because I'm still going to end up doing the same thing, let me show you what we would normally do next. These 2 equations that I would have simplified, I'm then going to come up over here somewhere, and I'm going to write these 2 equations as a system of 2 equations and 2 unknowns. Okay, so I would have this system of equations, 3x plus 2y equals 15, and then that second equation, in this case, 6x equals 18. Now from here, I would be able to ask myself, do I want to solve by substitution? Do I want to solve by elimination? Because this equation here happened to get rid of my y variable as well, I can simply solve this. I have 6x equals 18. When I divide both sides by 6, I get x equals 3. So now I've got one of my solutions here. Okay, I can plug that solution into this first equation in that new 2 system, 2 variable system, and replace the x. So I'm going to have 3 times 3 plus 2y equals 15. 3 times 3 is 9. So when I subtract 9 from both sides, I end up with 2y equals 6, or y equals 3. And then last but not least, what I'm going to do is, now that I have both x and y, I'm going to use one of my 3 equations, or one of my equations from the original problem. And since I did substitution, this equation that I solved for that variable that I substituted, this one is already solved for that last missing variable. So I'm going to go ahead and use it to my advantage. So here I'm going to have z equals negative 2 times x, which is 3, plus y, which also happens to be 3, plus 4. So when I simplify here, I'm going to have z equals negative 6 plus 3 plus 4, or z equals positive 1. Okay. Typically with systems of equations, we would always write our solution as a point, as an ordered pair. When we're dealing with ordered triples or 3 variable systems here, we're going to write it in terms of x, y, and z in alphabetical order. So here my solution then as a point is going to be the point 3, 3, 1. Okay, if you want to check your solution, you can always take this and put it back into your original equation or into the original equations of your system and check to make sure that everything works out. Okay, let's take a look at elimination. So also sometimes called the linear combination method. Elimination is where I'm going to take a particular equation and I'm either going to add it or subtract it or possibly multiply it by a value and then add it or subtract it to another equation such that I eliminate a specific variable. And I'm going to do that twice, right? Maybe I'm going to use equation 1 to eliminate x in equation 2 and then use equation 1 again to eliminate x in equation 3. And what I would be left with then are two equations that only have y and z. Okay. So once you do that, and again, the really important thing is that you have to eliminate the same variable in both of your elimination steps. It doesn't do us any good to eliminate x in the first elimination step and then eliminate z in the second elimination step, because then I'm still going to have two equations that now have three variables and I've got a problem there. Okay, once we get to two equations with only the same two variables left, now I'm going to solve using methods from Alg2 again. Okay, so again, here I've got a system. This system happens to be x minus 3y plus 3z equals negative 4, 2x plus 3y minus z equals 15, and 4x minus 3y minus z equals 19. So I'm going to go ahead and I'm going to get myself a little bit of room down here again. Okay, and I want to look at this and think to myself, is there a variable that's going to be really, really easy for me to use to try and get rid of another value or a variable in my other two equations? And right off the bat, the one that sticks out to me is x in equation number 1. Okay, I can multiply equation number 1 by negative 2. And when I add it to equation 2, I'm going to get rid of this 2x here. And then I can do my second elimination step, multiply equation number 1 by negative 4. And when I add it to equation 3, I will get rid of this 4x here. Okay, so let's go ahead, let's do that and see what it's going to look like. So the notation that I use so that we can follow the work later on, I'm going to write down the equation that I'm manipulating first. So I'm manipulating equation 2. By adding negative 2 times equation 1 to it. So I want to actually write the equations in the new equation 1 once I've multiplied down here below this. So I'm going to have 2x plus 3y minus z equals 15. And when I multiply equation 1, pardon me, by negative 2, I'm going to have negative 2x plus 6y and minus 6y equals positive 8. Okay, I said I wanted to add them together. Okay, one thing I would caution you against is saying you're going to subtract them, because oftentimes you'll subtract this first term that you want to eliminate and then you end up adding the others. So I would rather add negative whatever times an equation, because you're going to make fewer mistakes that way. So when I add them, the x's go away. 3y plus 6y gives me 9y. And negative z minus 6z, that should be a z, not a y, is going to give me negative 7z and equals 23. So just like before, I'm now going to put a box around this. This is an equation with two unknowns. Okay, I'm going to do my second elimination step. I'm going to take and manipulate equation 3. I'm going to manipulate it by adding negative 4 times equation 1 to it. So again, I'm going to copy down equation 3. I haven't changed it, so I'm going to have 4x minus 3y minus z equals 19. And when I multiply negative 4 times equation 1, I'm going to have negative 4x plus 12y minus 12z and equals positive 16. Okay, Okay, again, I'm adding these together, and it's also a really good idea to glance and double check your work. Make sure that all of your math, the simple math that you're doing with multiplying, is correct. All right, so I'm going to add everything together. My negative 4x plus 4x is going to go away. Negative 3y plus 12y is going to give me 9y. And negative z minus 12z is going to give me negative 13z. And equal to 19 plus 16 is going to give me 35. So again, I'm going to throw a box around this. Okay, this is my second equation in my system of two. So I'm going to take these equations, I'm going to rewrite them as a system of two equations and two unknowns. So I'm going to have 9y minus 7z equals 23. And I'm also going to have 9y minus 13z equals 35. So here it didn't quite work out as nicely as it did in the last example. I've got a little bit of work left over to do. But if you notice that both of my y values have the same coefficient. So what I'm going to do is I'm going to essentially take, doesn't matter which way, I'm going to take equation 1, let's say, and from it I'm going to add negative 1 times equation 2. So if I rewrite equation 1, I've got 9y minus 7z equals 23. And if I multiply equation 2 by negative 1, I have negative 9y plus 13z equals negative 35. So now I want to add these two equations together. 9y minus 9y is going to give me 0. Negative 7z plus 13z is going to give me 6z. Excuse me. And 23 minus 35 is going to give me negative 12. So I have 6z equals negative 12. I divide both sides by 6 and get z equals negative 2. I'm going to throw a box around it. I have my first answer, or first part of the solution here. Okay, I want to take that, I want to substitute it back into one of my two equations here in my system of two. Doesn't matter which one, I'm going to do whichever I think is simpler, so we're going to use the first one. So I'm going to have 9y minus 7 times negative 2 equals 23, which is really going to be 9y plus 14 equals 23. So when I subtract 14 from both sides, I'm going to have 9y equals 9. Or y equals 1. I now have my second of three parts for this solution. Okay. Now, I want to take those two individual values and I want to plug them back into one of my three equations from the original problem. Okay. Again, it doesn't matter which one I choose. I want to use whatever's probably going to be the simplest for me. And my first equation, x has a coefficient of 1. So I'm going to use that equation for this last substitution. So I'm going to have x minus 3 times my y value, which is 1, plus 3 times my z value, which is negative 2, equal to negative 4. So when I simplify here, I'm going to have x minus 3 minus 6 equals negative 4, or x minus 9 equals negative 4, and we get x equals positive 5. Again, I'm going to write this as an ordered triple in x, y, z form. So here I get the solution 5, 1, and negative 2. Okay. When we're going through and we're dealing with systems of three equations and three unknowns, really substitution or elimination is pretty much going to work for any problem. There's not one method that only, or some problems that only one method is going to work for versus the other. Okay, a lot of students, especially at this level, they tend to pick and say, you know what, I like substitution better than elimination, or maybe they like elimination better than substitution, and they go through and do every single problem using one of the two methods, whichever they are most comfortable with. To be completely honest, I'm totally fine with that at this point. All right, if you're able to do one of these methods but you're not comfortable with the other, by all means go ahead and stick with it for now. All right, I'm showing you guys both, but if you like one, please use the one that you're most comfortable with. Okay, last but not least here, all right, I have The next system of 3x minus y plus z equals 3, and x plus y plus 2z equals 4, and x plus 2y plus z equals 4. I want you guys to give this one a shot before you come into school tomorrow. If you don't get it, it's not the end of the world, but I want you guys to try this one and see if you get it. The solution that you should get is 1, 1, 1. Okay, we can do this one in class when we get in tomorrow, and we'll do this as a group, and or maybe talk through some of the different methods that you guys came up with. Did you use substitution? Did you use elimination? Which variable did you substitute for? So on and so forth. I think it would really be able to generate a pretty good conversation for us. All right, so take a couple minutes. I want you to go through, work through this problem, try and get to that solution of 1, 1, 1. All right, if you get to an answer and it's different than that, go back and see if you can find your mistake. A lot of times it's a very, very simple arithmetic mistake that kids will make in these problems that causes quite a bit of headache. Okay, again, by all means, don't beat yourself up for 30 minutes trying to figure this problem out. If you're stuck, if you're frustrated, it's okay to throw in the towel. We're going to go over it tomorrow in class. All right, hope you guys followed everything here in this video, and have a good night, and we'll see you tomorrow.